Okay, this is a video on to continue our discussion about phase diagrams. Last time in class, we looked at a hypothetical phase diagram just to kind of get the conversation going, get kind of used to the nomenclature and so forth. And now I've got an actual phase diagram. In this case, it's a copper-silver phase diagram. And just like before, we have the liquid phase up here at the top. And then over on the left, far left, there's an alpha solid. And the far right, there's a beta solid. Between any set of single phase regions, and then there's a two-phase region. So right in here is the alpha and liquid. And over here, the beta and liquid. And down here is the alpha and beta. The eutectic is at this point right here, where we can have liquid, alpha, and beta in equilibrium. That occurs at the composition of 71.9. That'll be in terms of weight percent silver. And I can write that eutectic reaction as liquid at 71.9, weight percent silver when it's cooled through the temperature 779. Transforms to alpha, one of the solids, and there's the composition of the alpha, 8 weight percent silver. And then it also transforms into another phase at the same time that's we call beta, and the composition of the beta is 91.2 weight percent carbon. So all of my information about that reaction is here. The names of the three phases, the compositions of the three phases, and the temperature at which that happens. So we're going to look at a couple of different compositions. We'll look at 5%. We'll look at 20%. And we'll look at 50%. And then we'll also look at the eutectic composition, 71.9%. At each combination of temperature and composition, I should be able to describe the phases present. That's the first question. Second question, composition of each phase present. And the third is the relative amount of each phase. So here I've got those three things at the bottom. And I say I've got 5 weight percent silver. It's cooled slowly from all liquid to 800 degrees C. So here's 800 C. This about up there is our 5 weight percent, because this is 10. So when we cool to, when we have that silver that has 5 weight percent silver, the alloy with 5 weight percent silver, and we're cooling it and we stop at 800 degrees C, then we're asked questions about what's present. And I'm in the single phase region. The only phase that I have present is alpha. And that alpha has the composition equal to what we started with. It's 5 weight percent silver. The relative amount of that, well, there's only one phase, so it's 100% alpha. So notice that notice that, sorry, I'm just distracted. I lost my options of other colors. Notice that I've got my answer to the question of composition is in terms of the x-axis. My answer to relative amounts is just percent. Okay, so that's at 800 degrees, and I've cooled slowly from all liquid. It says now I'm going to cool further to 600, and so now I'm about there. Let's try. If I could get a little closer. There we go. So now I'm right there. I'm in the two-phase region. So once it's cooled to 600 degrees, as it crossed this line, which we call the solvus, between a single phase of solid and two phases of solids, the alpha that was present could no longer hold as much silver in it. And so beta, which is high in silver, started to precipitate at the alpha grain boundaries. So above, at 800 degrees, if I were to be able to look at this solid, I would just see grain boundaries. And this is all alpha solid. But now, when I cross the solvus line, along those grain boundaries, I start to precipitate out beta at the alpha grain boundaries like that. So I still have alpha, but beta is precipitating at the alpha grain boundaries. Okay, so questions that were asked. What are the phases? What's the composition of each phase? What's the relative amount of each phase? So I know that I've got alpha and beta now. The alpha phase composition is wherever this endpoint is, right there. If I were to read that down, I'm going to estimate that that's at about 3. So alpha is about 3 weight% silver. And the beta, way over, we're at 600, composition is, we'll say 96. Okay, now the relative amount of each phase, in order to calculate that, I use something called the lever rule, which we just began to look at last time. So how I do the lever rule is I draw a lever, a line. The fulcrum will be at my composition of my material. So the fulcrum is at 5. On the left, I am going to put my alpha, and it's at a composition of 3. On the right, I'm going to put my beta, and it's at a composition of 96. All right, so in order to calculate the relative amount of alpha over here, I need to take the length of the line on the opposite side of the fulcrum, this length, which is 96 minus 5, and divide that by the whole length, which is 96 minus 3. Okay, that's to calculate the relative amount of alpha. I calculate that by measuring the length on the other side of the fulcrum over the total length. So the percent alpha is equal to 96 minus 5, which would be 91, over 96 minus 3, 93. And that is 91 over 93. That's 98%. If I have 98% alpha, I can just subtract that from 100 to know the percent beta. But just so you have an equation, the percent beta is going to be the length on the other side from beta on the other side of the fulcrum. And the beta is over here, so it's this length. Opposite side of the fulcrum. So it's 5 minus 3 over 96 minus 3. So 5 minus 3 is 2 over 96 minus 3, 93. And we know that should be 2%. So again, notice compositions are weight percent, relative amounts are just percent. Okay, so that we took that was our 5% weight, 5 weight percent silver cooling slowly down to 600. So let's look at a 20 weight percent silver, do the same thing. Have that cool to 600 and then have it cool further to, cool to 800, then cool further to 600. So I'm cooling to 800 and then I'll cool further to 600. All right, so at 800, I'm in this two-phase region, alpha and liquid. So answer to the question, what are the phases present? I've got alpha solid and liquid. We don't give special titles to different forms of liquid because there's only one. All right, the composition of alpha is going to be right there where this 800-degree line intersects the this is the solvus. So, no, sorry, that's the solidus. So I've got, if I read straight down, I know that this point is 8. I might be a hair bigger than 8, but it sure just looks like it stays. It's still 8 at that temperature. So we'll say that the alpha is 8 weight percent silver, and the liquid we read across to right there, which sits, so that's 60, that's 70, I'm going to call it 66. All right, and then for our lever to calculate the relative amount of each, I've got my line. My fulcrum now is at 20. My alpha is, I said, at 8. And my liquid is at, we called that 66. So the percent alpha is the length on the other side of the fulcrum, 66 minus 20, so that's 46, over the total length. 66 minus 8 would be 58. This is for the percent of the thing on the left, which is alpha. So I need 46 divided by 58. That's 79% alpha. And the beta would be the difference, or 21%, but just so that we have our equation, I'm sorry, not the beta, the liquid. Liquid here, to find the relative amount of liquid, I take the length on the other side of the fulcrum, which would be 20 minus 8, divided by the total length, which is 66 minus 8. So that's 12 over 58, which is 21%. Okay? And so now we'll cross to 600 degrees. So I've got my 20 weight percent 20% silver alloy, and I'm at 600 degrees. And I want to know what phases are present. Well, now I'm in the 2 solid phase region. So the phases present are alpha and beta. The composition of the alpha is right here, which if that's 5, I'll say 3, it could be 4, I'll say 3. So alpha is 3 weight percent silver. And then beta composition is over here at the other end, right there. And when I was at 600, I said that that was 90. Oh, we didn't have that before. We were over here. Okay, so my composition, I'm right here. I'm going to drop down. It's going to be 90. I'll call it 96. So beta has 96 weight percent silver in it. Now notice, these two numbers don't add up to 100. They might, they could, but that would be a coincidence. Those numbers, the compositions don't add up to 100. The relative amounts do. So to do the lever here, my fulcrum is again at 20. And my alpha is at 3. And my beta is at 96. So the percent alpha, the relative amount of alpha, is the length on the other side of the fulcrum. So that's 96 minus 20 over the total length, 96 minus 3. So it's 76 divided by 93. %. 82% alpha. And then the relative amount of beta is, here's beta over on the right, so I take the length on the other side, 20 minus 3, and divide it by the total length, 96 minus 3. So that's 17 divided by 93. So 17 divided by 93. And I should get 18% because these two numbers should add up to 100, and I do. Okay. Again, the 3 things that we can determine on a phase diagram, given a temperature and composition are phases, their compositions, and their relative amounts. Okay? So let's look at the 50% alloy. So that's right here, and we're gonna stop at 800 degrees. So we're in the liquid and alpha region. That's the answer to the first question. What are the phases present? I'll go ahead and on this slide, I was at 50% in phases present and at 800, so that's the alpha in the liquid. And then compositions, and then relative amounts. And then this would be 600. Yeah, so this should say 600. And I think I just did that. But I'm going to put a pause here just to make sure. Okay, I don't think I had gotten to the 600 point here. If I had, I apologize for repeating myself. But we're at the 50% silver alloy, and now we're cooling to 600 degrees right here. Oh, that's 50, sorry. Let's erase that. And 50 is here. Okay, so right there, I'm in the two-phase region, alpha and beta. The composition of my alpha is way over here. Oops. Oh, my alpha's composition is right there. I think we decided to call that 3. So my alpha is 3 weight percent silver. And the beta, I'm going to call that 96. So my lever, oh, I'm jumping ahead, I apologize. Put these on the next slide. So the only thing I needed for this slide was whether phases are present. Next slide, compositions. Alpha is 3 weight percent silver, and beta is 93 weight percent silver. So this for alpha comes from this point there, and this 93 comes from that point there, and that should be 96, shouldn't it? So those are my compositions, and now I can do my relative amounts. So again, alpha was 3 weight percent silver, and beta was 96 weight percent silver. And I'm still at 50. So my alpha is at 3, and my beta is at 96. So the percent alpha is the opposite from the fulcrum, opposite from where alpha is, that length, 96 minus 50, which is 46, divided by the total length, 96 minus 3. And the percent beta, 50 minus 3, which is 47, over total distance is 93. So these two are very close to 50-50. Just one sec, I need more light. Okay, 46 divided by 93, yeah, 49.4. So we could probably say alpha is 49% present and beta would be 51. Close to 50-50. All right, so what do we have next? I swear I just did this. There we are. Okay, so here I say I've got a eutectic alloy, which means I've got an alloy that's right at this 71.9 weight percent silver. And so when it's cooled to 800 degrees, it's still liquid. So there's liquid present here. And yeah, this is repeated. Just liquid present. Composition, it's just liquid. The composition will be the same as the alloy composition. So liquid with 71.9 weight percent silver. So whenever there's only one phase, then the composition of that phase is the same as the composition of the alloy. When there's only one phase, the phase composition is equal to the alloy composition. And if there's only one phase, then the relative amount of liquid is 100%. I don't need to use a lever. All right. So let's go then to this same alloy, the same eutectic alloy, cooling it to 600 degrees. So now I am right there in the two-phase region. So I've got alpha and beta. The composition of the alpha was 3. The composition of the beta was 96. We did this before. Alpha is 3 weight percent silver. Beta is 96. The two endpoints of my isotherm. And I was supposed to put that in the next slide. $71.9. Okay. So my fulcrum is at 71.9. My beta is at 96. My alpha is at 3. So the relative amount of alpha is going to be the length on the other side of the fulcrum, which is 96 minus 71.9, divided by the total length, which is 96 minus 3. So percent alpha is, I'll write this out, 96 minus 71.9 divided by 96 minus 3. So that's 26%. And the percent beta should be 100 minus 26, or 74%, but we can calculate it. Percent beta would be 71.9 minus 3, which would be 88.9. 71.9 minus 3 divided by 96 minus 3. So 88.9 divided by 93. Okay, that's not, what am I doing? Oh, this should be 68. Sorry, math error. This difference between 71.9 and 8 and 3 is 68. .9 divided by 93. There it is. I expect my number to be 74%. When it wasn't, I knew that there was some error involved. So 74% beta. Okay? So we looked at the composition. Let's just go to a blank one. We looked at the composition that's this is a crappy drawing. Let me try this again. Now won't have the same values. I'm wanting to just talk about method here. So we looked at, in our case it was a 5%, but we looked at an alloy that was to the left of this value. We looked at an alloy that was between this value and the eutectic. Actually, we looked at a couple. We looked at 20 and we looked at 50. And then we looked at the eutectic composition. Just now. Those are the things. This was a 5, this was 20, this was 50, and this was 71.9. And again, I know that that's not proportionate to the drawing. Okay? So for homework number 4, I want you to, for an 80% silver and what was that? We'll say at a 97%. For those two compositions, answer the 3 questions that we've been asking. At 8, and ask those questions at 800 C and 600 C. So that'll be, we'll call that part 1 of homework number 4. All right. I'm going to post another video that just only talks about the microstructures that we would have seen at each of those temperatures and compositions. And I want you to do the same for these 2 compositions. That's the second part of homework 4. And then I'll probably just upload these questions and the diagram and such onto Blackboard, so you could just use that. But this is the end of part 1 of the phase diagram, looking at eutectic phase diagrams. It's about 5 o'clock now, p.m. on Monday. I will post this, I'll upload this, and I'll post the second part with the microstructures later tonight. Thanks.